Everything that has a beginning has an end. Stars die, planets die, even galaxies eventually fade. But what about the universe itself? Will it go on forever? Or will there come a moment when time itself stops? These are not idle philosophical questions. They are questions rooted in physics, in the behavior of dark energy, in the fate of matter and light. And the answers are as profound as any we can ask. Today, we're going to explore the possible ends of the universe, not just one scenario, but several, each with its own physics, its own timescales, and its own implications for what it means to exist. Some of these endings are cold and quiet. Others are violent and spectacular. And one of them might already be happening right now. Let's look at the final acts of our cosmos. The Big Freeze. The most widely accepted fate, based on current observations, is the heat death, also known as the Big Freeze. This scenario assumes that the universe will continue expanding forever, gradually cooling down as it does. Stars will burn out. Galaxies will drift apart. The last stars will exhaust their fuel and die, leaving behind white dwarfs, neutron stars, and black holes. Over trillions of years, even those will fade. Black holes will slowly evaporate through Hawking radiation, becoming smaller and smaller until they vanish in a final flash. In the end, the universe will reach a state of maximum entropy. Everything will be evenly spread out at nearly the same temperature, just above absolute zero. No more energy gradients, no more work, no more light, just a cold, dark, empty void. In this scenario, time doesn't end, it just becomes meaningless. Nothing ever happens again. It's the slow, quiet death of the cosmos. The tearing of reality. But there's a more violent possibility. If dark energy, the mysterious force driving the accelerated expansion of the universe, is not constant but increasing in strength, then we face the Big Rip. In this scenario, the expansion doesn't just continue, it accelerates without limit. Galaxies will be torn apart from each other. Then the Milky Way itself will be ripped apart. Stars and planets will be torn from their orbits. In the final minutes, the expansion becomes so powerful that it tears apart planets, then molecules, then atoms. Finally, even the fabric of space-time itself is ripped apart. The universe ends not with a whimper, but with a catastrophic, instantaneous shredding of everything. The Big Rip would happen in a finite time, a specific moment in the future when the expansion rate becomes infinite. How far away? It depends on the properties of dark energy, but estimates range from tens of billions to 100 billion years from now. A collapse. Before dark energy was discovered, many cosmologists thought the universe might eventually stop expanding and collapse back on itself. That scenario is called the Big Crunch. Gravity would reverse the expansion, pulling everything together. Galaxies would merge, clusters would collide, and eventually, all matter would be compressed into a single, hot, dense point, a mirror of the Big Bang. In a Big Crunch, the universe would end in fire, not ice. Temperatures would rise to unimaginable levels. Stars would be vaporized. Atoms would be crushed. The universe would become a singularity. And then, what? Some theories suggest that a Big Crunch could be followed by a Big Bounce, a new Big Bang, creating a cycle of birth and death. The idea is appealing, but current measurements show that the expansion is accelerating, not decelerating, making a Big Crunch unlikely unless dark energy changes its behavior dramatically. A quantum apocalypse. Now we get into more speculative territory. In quantum field theory, the vacuum of space is not truly empty. It has a certain energy, the vacuum energy. Our universe might be in a false vacuum, a state that is stable but not the lowest possible energy state. If it decays to the true vacuum, it would create a bubble of new lower energy space that expands at the speed of light. Inside that bubble, the laws of physics would be different. Atoms might not form. The fundamental forces would change. If a vacuum decay event happens anywhere in the universe, the bubble would expand forever, destroying everything it touches. We would never see it coming because it moves at light speed. One moment we're here, the next, the universe is replaced by something entirely different. It's a terrifying scenario, but also one we can't predict. It could happen tomorrow, or in a billion years, or never. A distant future. Let's talk about when these events might happen. The heat death is the slowest. The last stars will form in about 1 to 10 trillion years. After that, the universe will enter the degenerate era, a time of white dwarfs, neutron stars, and black holes. Those black holes will evaporate over timescales of 10 to the power of 67 to 10 to the power of 100 years. The universe will then be a dark, dilute soup of particles. That's a timescale so vast that our minds can barely comprehend it. The Big Rip, if it happens, is much faster. Depending on the model, it could be tens of billions of years from now. The Big Crunch, if it happened, would also be tens of billions of years away. Vacuum decay is the wild card. It could happen at any time. But all of these timescales are so far beyond human experience that they are, for all practical purposes, infinite. The end of intelligence. No matter how the universe ends, life as we know it will vanish long before the final act. The Earth will be swallowed by the sun in about 5 billion years. The last stars will die in trillions of years. But intelligent life might find ways to survive, perhaps by harnessing energy from black holes, or by moving to other galaxies, or by uploading consciousness into computers. Some futurists have speculated about civilizations that could exist for trillions of years, carefully managing their energy. But eventually, entropy wins. Even the most advanced civilization cannot escape the second law of thermodynamics. Eventually, there will be no usable energy left. The end of the universe is the end of everything that can think, or feel, or remember. It's a sobering thought, but it also makes the time we have now all the more precious. Which one is most likely? Based on current data, the heat death is the front-runner. Observations of distant supernovae and the cosmic microwave background indicate that the expansion of the universe is accelerating, driven by dark energy. If dark energy remains constant, a cosmological constant, then the universe will expand forever, cooling into heat death. That's the simplest and most consistent model. But we don't know if dark energy is truly constant. It might evolve over time. Future missions like the Nancy Grace Roman Space Telescope and the Euclid mission are designed to measure dark energy's behavior with high precision. If they find that dark energy is strengthening, the Big Rip becomes possible. If they find it's weakening, other scenarios, like a big crunch or a bounce, might re-enter the conversation. For now, the heat death is the best bet, but we're not certain. The meaning of an ending. The end of the universe is a strange thing to contemplate. It feels distant, abstract, almost irrelevant to our daily lives. But in a way, thinking about the end forces us to think about the beginning and about the fleeting nature of existence. The universe gave us the stars, the planets, the elements in our bodies, and the time to wonder about it all. Whether it ends in cold silence, a cosmic shredding, or a new beginning, it will have been a remarkable journey. And perhaps the most remarkable thing is that we, a tiny speck of life on a tiny planet, can even ask the question, We are the universe becoming aware of itself, even if only for a moment. What do you think? Does the thought of the universe ending bother you? Or does it make you appreciate the present more? Let me know in the comments. Thanks for watching Daily Dose of Space. Stay curious, and I'll see you tomorrow.